4.3, connecting f prime and f double prime with the graph of f. So in this section, we're going to be looking at how the first derivative and the second derivative relate back to the original graph of f. So right here in this example I have pulled up, we will look at some different examples of how the derivatives actually affect the function. So first, let's focus in right here. Here we have an absolute minimum. As we know that this is the smallest point on the graph. What I want you to pay attention to is that the derivative here is positive. All the tangent lines here have a slope of going up. That means that if this point is a local min, or an endpoint, and the derivative to the right of it is positive, then we get a absolute minimum, or a local minimum. Notice here that we have no extreme value. However, the derivative equals 0, so it should be a critical point. But we notice that on both sides of the critical point, it's always increasing. So here this tells us that there is no minimum or maximum right here. As we continue on, you'll notice that the derivative here was positive and the derivative here was positive. That's another way of us telling, using that sign chart, that there is no minimum or maximum. So now let's look right here at this point where we have a local max. We have that the derivative is equal to 0, so we have a horizontal tangent, and we have that from the left the derivative is positive, and from the right the derivative is negative. And you'll notice here that it bends up and then bends down. So this is called concave down, because the whole thing, it's like an upside down U. And we'll get into the second derivative. Here we have a local min because the derivative here is negative and then becomes positive. Notice here that the derivative is undefined. However, same thing. The derivative over here is positive and the derivative over here is negative. Here we have no extreme because the derivative is negative and the derivative continues to be negative. So this is a very good example of why critical points exist and where the critical points actually give you max or mins. So I'm going to go into some rules for the first derivative test. So notice that f may have a local extrema at some critical values while failing to have them at others. When f has a minimum, f prime, which is less than 0 on the left side, and f prime is greater than 0 on the right side, and vice versa for the max. So as we just talked about. What this means is, if the derivative changes sign at a critical point, then there is a max or min. And that's something we've been talking about using the first derivative test and the sign charts. Okay, so now let's go into a theorem and talk about some first derivative tests. So this is basically the sign chart that we've been making the whole time. You have a local max if at one side of it, so here's at C, the derivative, this is f prime of x, if the derivative on one side is positive and the derivative on one side is negative, you have a local max because it has to reach a higher point. That's if the derivative equals 0 or if the derivative is undefined. Conversely, if we have this point C and the derivative is negative and then positive, we get a local min, both where the derivative is 0 and where the derivative is undefined. If f does not change sign, or if the derivative does not change sign, so if where it's 0 or undefined, it does not change sign, so it stays positive on both sides or stays negative on both sides, then we do not have an extreme value. We do not have a max or min. Endpoints, however, if you have a left endpoint and then the derivative is negative, you have a maximum. If you have a left endpoint and the derivative is positive, you have a minimum. For a right endpoint, it's the exact opposite. If the derivative is negative going to a right endpoint, you have a minimum. And if the derivative is positive going to an endpoint, you have a maximum. These are things that we've noticed using the sign chart, which it makes it very easy having something like this, where these are our endpoints and we have arrows pointing, telling us what our max and mins are. We're going to be using this throughout this section and the next couple sections to determine maximums and minimums.